So yeah, just to continue the discussion here. So Jonas showed us an overview of Firebase as a database solution that we can use for for your projects, of course, yourself, but specifically, of course, for the cloud cores. And the nice part is it has bindings for so many programming languages, right? So you can use it from JavaScript, from Java, of course. They're for Android, Kotlin, Go, say the least, because it's Google Tech, so they're kind of open to their own ecosystem quite naturally. But it's really worthwhile knowing this because also it's not only yet another Google service, but rather it's a good general tool to know when in order to learn the concept of NoSQL databases or alternative storage formats, because you guys are used to relational databases. So of course the natural thing would be to hook it up to some sort of MySQL or MariaDB or any of the ones you kind of hopefully already know from the databases course that you're taking at the same time, I believe, right? At least the second years. Good, they're nodding, so that works. But we also show you alternative storage mechanisms. So Firebase is one of them. The other one is MongoDB. You want to acquaint yourself with this one as well. There may be a session later on about it. Marius has posted some links to his past lectures, and they're actually quite instructive. So you can just follow those to get more insight into MongoDB. But for this iteration, for this year in particular, we're thinking about more relying on Firebase for dealing with data, because it's a very reliable service, very flexible service. And I think it's also good preparation for being acquainted with this ecosystem, because we'll use it more in other courses as well. And Yona showed you how to use it, basically using the service account, so don't shy away and play with this. Yona will upload the demo, I believe, right? Yep. So everyone can do that, and that's relatively straightforward. It's actually quite amazing to see with how few lines of code you get very reliable and secure services, cloud services connected to your local app, right? So there's no extensive setting up, specifying tables and all that kind of jazz. You just bluntly say, hey, store this in some sort of collection and make it retrievable again at the end, right? Of course, what wasn't shown there was the ability to select, to perform queries and things like this. So those would be advanced features that we come back to at a later session, but just to give you an initial nudge to look into this tech in the first place. Okay, apart from this, I'll completely ignore the usual criticisms, that is that we don't take breaks, and simply not take a break. Because one of the things we have been asked, or a few of the things that I want to discuss briefly is we have a changed assignment 1. Who noticed that? A subset, roughly 1/3 reads our wiki. That's pretty cool. I was expecting less, but 1/3 figured it out. So issue is there. We had a beautiful little assignment. We thought everything was clever and worked quite well, but didn't, because we needed an API token, and the chosen service, while sustainable and while environmentally responsible, didn't really provide the tokens as fast as it should have. So we rewrote the assignment to actually make sure we have a service that we can actually use in the assignment, right? So the idea is, as before, to make some information about endangered species available using your web services by country, by species, and have some sort of diagnosis endpoint that you want to set up. And you are supposed to use 2 external web services. That is one, the countries API that restcountries.eu that we looked at when we talked about REST initially. It's relatively straightforward. And the second one is the Global Biodiversity Information Facility, GBIF. Always reminded of Giphy every time I read this. But what is that doing? Well, it's basically an international network and research infrastructure to provide open access to data about life on Earth. So it's pretty good. And we're going to use that for you to actually create your first service. So if you haven't had a look at it, the refined assignment, please do so. And I think it's really timely for you to start planning on actually setting it up, given that it's a bit... How many actually started on the assignment already? Good.
Good.
How many get stuck on the assignment already?
Good.
What was the reason? You're not helping, Jona. So what were the issues you got stuck on? The API token or something else?
No, so the trouble I'm having is that you have to query the GBIF for 3 different things.
Yeah.
As well as having so when you query a species, you don't get if it's extinct or not.
Yeah.
And then you have to query just just search is extinct true, then they actually get the JSON bool extinct true or not. But you don't get it if you search on a species.
Right.
So if you check the species, then you have to, or first you have to, from my understanding, you have to go to occurrence to see what species are in a country.
Yeah.
Then you have to search for the species to get the name.
Yeah.
And then you have to go through all of them with the search is extinct.
Yeah.
And then you have to check all of the things you got from the country, from the right country, and then you have to check if they are extinct.
Yeah.
So it's a bit weird on how you're supposed to merge all of them together.
Yeah. So exactly. So and this is actually intentional part of the exercise, because that's the issue with those REST APIs. Otherwise, you could just point the people, use that API and you get the information about the animal. But you're right. So the issue with APIs is that they're not always they're well specified, but they are not always made for your purpose you're using them for. That's the key idea. So sometimes you need to combine and perform multiple queries and integrate them into some sort of data structure iteratively. So, and that's what this exercise is in part about, to not ensure, well, it's not like two queries and you combine two API calls and then produce the data structure and send it to the user, but it's actually how do you cleverly combine this in the first place. So you're on the right track, actually, that's the intent. What's the problem you're facing? I mean, apart from the fact that it's super complex and requires you to learn a lot about the messiness of REST APIs, what's another issue with this? It's a very practical concern. It's a very good point.
What's the limitation that you'll have to consider when querying an API?
Rate limit.
Yeah.
So I didn't get it.
Rate limit.
That's right. What is that?
It's you usually for all APIs you get the limit of how often you can query that API.
Yeah.
It's usually like I used a service that had 100 per second or 10 per second over a long amount of time.
Yeah. That's right. So rate limits are a bit of an issue. Who ran into rate limits yet? Good. Because we should have talked about this before we gave the assignment, not after getting the assignment, else they block the entire new IP address set. So the issue there is exactly that, right? So that people muck around too much, and a general fear is that you are basically scraping their service, setting up your own service and using their data, things like that, right? So, or DDoS attacks or anything of the like. So the complexity is, as you say, we need to build this up incrementally, having multiple queries against the same API and bringing it together. But in the development process, that half the time goes sideways, right? So one query works, the other one doesn't. You need to figure it out and so on. How can you optimize your development process so that you, on the one hand, get your work done and you can use it as often as you like, but on the other hand, don't hit the rate limit? How do you deal with this? Any ideas? Well, for the sake of diversity?
I was thinking of using previous results to continue searching.
Aha. Can you elaborate on this?
Essentially trying not to repeat the same API call.
Yeah.
Is there a term for that?
That's a good one. Is there a term for that? Anyone else wants to bring out the term? You're so in.
It's a cache.
Yes, caching.
Yeah. So in anticipation for a future call to the same resource, you just keep the results. Why can you do that most likely?
It's because the queries rarely change over time, or they might say every month you update the cache for this or something.
Yeah. Or for testing you just don't care if they change because you just want the testing data.
Yeah.
Exactly.
Right. I mean, yeah. So accuracy is secondary to this exercise. Right now, it's really getting stuff going. Right. When it's then going live, then you can go back to have a shorter cache timeout or whatever else, or completely abandon it again. But fundamentally, caching is the key idea. That's absolutely right.
You can also rate limit if you find the service providers rate limits. You can rate limit your calls out to them as well.
Right. Yes, that would be one as well. Exactly. So you kind of accommodate their rate limiting by building it into yours, so you cache as long as you're below that given rate, right? It's a bit complex. It's a nice idea, right? Beautiful idea.
Very handy.
Very handy.
I'm doing the Python.
You should implement this. That's a good idea.
Can you elaborate what you said?
Right. What he says is basically, well, if you know, and I'm just trying to paraphrase you, but if you know the rate limiting of the service you're actually invoking, right? Yeah. For example, 1,000 requests per minute or whatever else, right? Then you can write your application in a way so it will never hit this threshold, right? Every time you're querying too fast, you just use cache results all the time. right?
Yeah, or what you do is basically just create like a service that just lets, let's say 1,000 per minute through them. So you just call 1,000, you set up so you can do 1,000 calls. Then this service just blocks these like threads or whatever you have in the background for. So not everything has to go through this service, and that is rate limit instead of you have an external and you get 4 hours or 413 sometimes.
Right. So that's the complicated approach. That's possible. What other approach could you take in a development context? You heard Jona, or Jona said, well, we are not too interested about the accuracy of the results, right? Who cares? Because what we are primarily interested in initially anyway is the data structures, right? You want to ensure that you get some sort of animal back and the necessary properties, necessary fields. What do we have here? Kingdom, phylum, order, and so on, right? If it doesn't quite fit, that's fine, at least for the development cycle. So how can you deal with this? What's an alternative pathway? So one of them is mentioned, deal with the rate limiting by anticipating it. What's the other way? You know what's the other way?
Oh, sorry, I wasn't paying attention.
Oh, that's so sad. You're like all my other students. No one's paying attention. So bad. No. What's another pathway? How else could you do it?
Just rip the entire database use your own.
Yeah, that's aggressive.
Implement the API.
So let's do a merger of your two positions. Then I would say, yep, that is. So don't scrape the entire database, especially now it's on the stream. That's not a good idea. Anywho, so don't scrape the entire database, right? But you said something that was quite good. What did you say?
I did.
Yeah.
Re-implement the API.
Or
A small part of it.
right, the relevant subset of the API. Right? Why don't you mock this thing? Right? You know already after debugging and figuring out which queries you actually need, right? Can't you just set up, basically write a mini web service, and you see that's relatively fast. After you've done it 1 or 2 times, I think it's a kind of a no-brainer and go, right? So
yeah, I mean, once you get used to like having handlers and returning JSON structures, you're pretty much just like you kind of just copy the code from last time and then change what kind of files you read and then just send that. Yeah,
that's very practical. So you carefully rewrite it and ensure that you don't have bugs in your code, of course.
But the point is, reuse all your code and hope it doesn't blow up.
Okay, that's a pragmatism, yeah.
It probably will blow up.
It will. Of course it will blow up. Hence you construct it and groom it carefully from the scratch. Anyway, jokes aside.
Another reason to like you have well-documented code, by the way, so you can actually reuse it later.
Yes, that's actually a good point. If you write your REST endpoints nicely and you document even your code for yourself, at least you understand what you're copying, and then it's sweet. You can just copy it across, modify what you need. For example, content type, endpoints, and potentially the data you're returning, right? But the idea is come up with a mock service that basically, if invoked on a given URL, right? So you need to hook it into the correct handler, of course, in the main file. If invoked on a given URL, which is super straightforward and modifying, then it returns, for example, a standard set of values, right? So irrespective of the input query that you actually produce, right, with the endangered species category and so on, you just bluntly return a set of one JSON structure every time it's invoked. So you can just at least test, well, if I invoke the service, I get something back that corresponds to a structural format that I can process in my client application, right? So because it's actually getting a bit complex in the sense that you guys have built this service here, right? So you need to provide this service in a way that we, that is people here, I don't know what that is, that's us anywho. Us invoke your service, right? That's what you are building. What you are doing is actually invoking 2 other services, right? So in this case, and potentially multiple times, right? So, and this is the kind of the country service here, and this is the G database thing.
Yeah.
GBIF, I think that's the one. So that's the thing to get right. On the one hand, you're building a server anyway. So this one is a REST service that responds to user requests, right? GET requests most likely. Right? But on the other hand, you're also writing a client because you're a client to the other databases, right? To other REST services. What you want to do then is, if you have rate limiting in those ones, well, mock those ones, right? Instead of actually invoking the real databases, come up with a mocked version of it. So meaning, yes, you build yet another service. But again, as Jonas said, it's fairly reusable once you set up the code. And it just bluntly returns the fixed data structure, right? So that you, of course, got from the original service at some stage. But don't scrape the entire database, right? So just, have this query, get that string and basically have this dummy service instead of the actual service return the database. The only thing that you then need to modify when you go into production is the URLs, right? Because the entire interface, or subset of it, is reconstructed in your own service already. And there's also a nice way for testing. Why is that good for testing?
It's fast, and you can guarantee you have it, even if you don't have internet.
Ah, so that's
You
the
can
thing.
do it on the train.
You can do it on a train, exactly. So what's the other point about it? You're on the right track.
It doesn't change.
They say it doesn't change, right? So, and the idea is there that the testing web service is a bit hard, right? Especially you're sitting here, because you rely on external dependencies that may be available based on connectivity issues, based where you are basically, but also they may simply change over time. If you mock those, right, so you emulate a virtual version, you basically bring up a handler, a mock handler or whatever else, that you redirect to in the case of testing, then you can guarantee that you're actually literally only testing your piece of code, right? Because if you're only running tests and you assume that all the dependent services are actually available, you're not only testing your service, you're implicitly testing the availability of their services as well, right? And that's not something you want to do in the first place, rate limiting availability, but also you want to isolate issues, right? If you want to figure out, is it my service that is now, due to my modification, cocked up in a way, or if it's the actual database, because it could very much happen so that at the same time they actually had an issue, DDoS attack, or structural change in the actual REST service that you're using. So from an isolation point of view and testing point of view, it would be also wise to think about having this mock service, right? So that would be the pathway I would recommend you to take. So both to defeat the rate limiting issue, but also to make your service testable, isolate issues. Because your system is no longer trivial. It's not one system and then you are interacting with this. You are just basically hooking up a number of different systems. That's what the cloud or REST APIs are effectively about. The only thing you do, hold a bit of state in between, recollate all the information you need and present it back to the user as a JSON file in JSON format, right? And the user then, the response is returned in JSON. They can do whatever they want with this, right? But this is how those web services work internally anyway. They will rely on some sort of text sources, data sources, perhaps even Firebase, who knows, to actually produce the data and present them to you. And you're doing the same right now as well. So it's good to think about how you can do that reliably without hitting the rate limit. So please think about this when you start implementing, because if all of you start actually invoking the service, I bet they'll block the IP of it. So it's going. We had this in the past, so, and we should have mentioned it well before. So that's the small excerpt there. So strongly encouraged to think about this particular aspect. So the other thing is, we talked about versioning already last time. So that's good. It's important that you think about if you are in a position to create REST service, bear in mind that it's really worthwhile thinking about versioning, right, of those APIs, because APIs change. So if the country's REST API changes quickly, or the GBIF API changes, just imagine if you build a web service that builds on those two ones and someone else does this, builds on yours and so on, what the propagation effects are of simple changes in an openly available web service. So it's really professional for you to think about embedding versioning, and ideally in the URL already, in the URI already. So not just as some sort of documentation that sits on a website that no one looks at, but rather make it explicit in the UI. So people actually ensure that you commit to a certain structure and that people know which version they actually are bound to. Please.
If there's a chain of REST APIs, then does it get easy to know if something else of the chain has been updated, or
Again, repeat.
I'm thinking of since it's still possible to use the previous version. How can you easily know that it's been updated?
Right. So the idea would be, that's right. So you wouldn't necessarily know that. That's correct. The idea is there that you are building your interface, right, the structure you're using against the old database. If the REST EU countries, EU database and so on are updated, And here versioning generally refers to API update, not content update. Yes, they found a new country on the planet. Yeah, they added it. Okay, that's fun. But it's more along the lines the structure has changed, right? And that's where your code very certainly will break, right? So that's the kind of information you only find on a web page. So they write, okay, we have released a new version v2. Now see the root URL is now, REST countries v2 and so on. Then you need to have a look. Okay, perhaps they even describe in how far the API has changed. It's not something that is automated or embedded in the REST standard. But the idea is just that you commit to an explicit version, and rather as a provider of data, as an explicit interface. You can also say, well, version 1 will be faded out in half a year or whatever, right? And suddenly there's a 4.4 in response. That's fine. But it's I think really important to think about versioning in the first place, especially if you provide services, because unlike application services are kind of a bit more made for the long haul, right? We expect those. Especially since we don't embed presentation, which is very trendy, you have different forms and how you present country information and so on. But the data is, pretty much static, right? That doesn't change much. Sure, inhabitants and population, but the structure or information that we want about countries is reasonably static and at best expense rather than becomes less, right? So with this planning and thinking in mind, data structures, the versioning is incredibly important, just to, avoid propagation of sudden breaking, because REST services themselves are not, there's no semantic way of assessing if a version has changed. It will just break or not break, right? So but if you kind of provide some sort of guarantee as part of your professionalism in the form of a version, then you can mitigate this to some extent. So that's the whole idea behind it, right? Whether there are multiple versions and you want to stick to the old one and you don't upgrade it fast enough before it's expired, yeah, then it's on you, but at least you have a versioning concept as we have in software, right? Same thing. Yeah. Cool. Okay. Questions? Any other questions? Comments?
I still don't understand how you're supposed to connect the picture. A speech is 5 country key or country code, and all the ones that are extinct.
Yeah. So what's the strategy you took?
I haven't solved it yet.
Right, you haven't solved it.
So I've just queried now mostly countries.
Yeah.
And then species.
Species. So you get all the species and.
Yeah. So I just started to have, so I can just query all the species.
Yeah.
Just to understand how to do that.
Yeah.
And starting on occurrence now, and then I have to figure out how to actually put them together.
That's right.
I have no clue how to do that. So just starting to understand how it works.
So how can you hang on.
Let's say when you query species, for example, if in this example you get how to query a species or what answer you should have, you can get all the information except from the extinct part.
Right. So, but you have a reference to. Let me check. You have a reference to the actual to country, right? For a given species.
No.
There's no reference. Should be. So here's the limit. So that's nice. For the number of results, that's cool.
Yeah. I think
Get country, so that's the country.
Occurrence, I think.
Sorry, I didn't get.
I think country is in occurrence, I believe. So in slash occurrence.
Ah, occurrence. Right.
That's where you get.
So you get it. So hang on. So that's the API section. So we're here. In occurrence down there, right? So. Yeah, there you go. That's right. So get occurrence. So it basically does the full search across the occurrences, and then there's one feedback, and that's country. What is the format of country? Is it in country code or is it a written version?
Country code.
It's in country code, two digit or 3 digit one?
Yeah. Just go up, yeah.
Voila, yeah. So that's and this is what you have available. So that's the linking pin to the REST EU one as well, right? Because you have a 2-letter country code. So that's the thing. I was worried there was no reference to it. So that's the thing. The idea is to browse both APIs to understand them and see which queries make most sense to you, right? Think about like in a database context, right? So you want to unite them by a given country, by a given key. Well, you need to identify which tables can be matched in which way or related in order to create a reference between the different entries in the tables. And that's the same here. But the only difference is here that's 2 different services, right? Hosted by different providers and so on with different information. How do you integrate them, right? And here it's would be literally for you to drill down, okay, well, how do you get to country information for a given species? And how do I then get additional information for the country that's not available in this particular service using the other service as well? But there, the primary key is effectively then the 2-letter ISO code for countries. Please.
That's not for a given species. That's for all occurrences.
But it's a search here, right? So if you do a search, you get a country as research as response, and
I believe you get all species keys, I think. And then you have to query the species, and then you have to query the
country.
Extinct, and then cross-reference that with the species if they are extinct or not.
That's the idea. Yeah, this database is a bit more complex, isn't it?
I mean, we also dealt with the API giving like unreliable stuff back. Like depending on what we sent, we got different like data structures back. So having to deal with like how messy APIs are is
it's like, definitely one of the exercises.
Yeah, it's good. It's good to like you actually get introduced to that.
Some of the species don't have data.
Yeah.
So if you don't search for the right species, you might think, oh, this is
of course.
And you have to actually find the species which has all data available.
Right.
I think the only link would be the search really. And again, search is one because it searches across fields. I don't think you can constrain the searches for specific fields, which is a bit of a pity. It means you need to be reasonably specific about the species. But you can also twist that around and actually bring it back to the user. If a user, for example, enters a species only with a 2-letter code or whatever else, or requests a species with 2-letter code, you may want to ignore that request for for reasons of rate limits.
It said 200,000, so it should be quite hard to get there.
Sorry?
It said 200,000. It said on the page in the search that you have 200,000 queries.
Yeah, that's 200,000, right? Yes. Yeah. Yeah, but 200,000 is quite high anyway, right? So I wouldn't necessarily want to push that downwhere. So, but there seems to be the sensible move to use this as a merging starting point. Yes. So in any case, decompose the problem. See if you can figure out the necessary information both from the respective databases, and then think about the merging. You're stuck with the merging right now, right?
Yeah.
Okay.
Just understanding like what and in how order now is supposed to do like 5 queries to get just the if it's extinct or not. Because you search for country code, and then you have to go to occurrence or first to the country API, then occurrences, then species, and then species search extinct true, and then cross-reference the species for your country with the species that are extinct. But you have to also output all of the species that are in the country, but you have to specify which are extinct or not.
That's right. Yes. Yeah, that's a bit tricky in this one. This is a tough one.
To put a number to it, to find US, to search reference the US, you need a 1 million search because you can only get 1,000 at the time. So and they have 13 million different species. So we are going to run out. if they try to find, hey, what's extinct in US?
Yeah, that's probably a bit of a stretch. We like this large number stuff and the heavy load, but you're right, that will be a challenge.
So again, the issue here is that if you look at that structure, you get every piece of information except that extinct.
Right.
And then the only way to get that is to actually search is extinct equals true, but then you get all species that are extinct, or not, extinct.
Okay. I'll modify it. I have another idea how to do with this. How about you have a given species that's returned, right, with a link to the species, and then can do the search if needed from there for the extinction of that specific species. Now, does it solve that problem?
Can you repeat that, please?
If we add a link to the species from this particular from this particular response here, right? So if that's one of the return information, and we point to the API page specific to that species, would that solve the issue to some extent?
Figure out if it's extinct or not?
Not necessarily, but to have a reference to the species and use that as an input for the search.
When you do the search request, you can add the species as a parameter.
Ah, okay.
Or as a if you look at the huge list of parameters, you have country,
right.
and you can also use species key as a
for the search
for the get request
to
the API.
Cool.
To the GBIF API.
Yeah.
So if you know which species you're looking for, then you don't get a list of 13 million.
Right.
You get just
cool.
one.
Okay, that would be an angle. Okay, I'll modify the assignment accordingly to make that. So ignore the extinction bit for now. Just get the information from the API, and then we'll debug our way so we can kind of either do it as a secondary link to a secondary page, whatever. So we keep the option or remove it entirely. I'll muck around with this to see that's a bit more performing. But your point is good. Having 1 million calls is probably a bit above the average that we would expect for the assignment. Cool. Yes. Cool. So that's one of the things. We probably extend the deadline by a week or so for because it seems like because we fell a bit behind in terms of using the original API. But this should be sufficient to actually get this going. I'll work on the instructions in a bit and refine them a bit, but fundamentally ignore the extinction aspects. But we
probably or will.
No, we will. The probably is 1 week or which exact date.
Okay.
So I don't want to tie myself down to exactly 1 week.
But it will be extended.
Yes.
Okay.
But I will do it. I will type this in. I need to do a bit of planning and then I'll update the webpage accordingly. But I encourage everyone to at least get going writing their clients. And so the best approach, that was what Jona basically says, was to start writing a client and a server side interface basically for your REST services, because then it becomes incredibly easy to just juggle and combine them and use them and twitch them. Because one of the things that you want to separate is what is the challenges of dealing with the domain specific data, like parsing JSON and getting to that structure, from how do I build a client and how do I build a REST service, right? So then you have kind of ready-made skeletons for those purposes. Will make your life a lot easier, and then it doesn't sound as daunting if we're saying, hey, please mock that service, because it will be very, very simple. Right? So that's perhaps one strategy that we can bring along for you to ease the development. Okay, so we'll
I have a question.
muck around. Yes, please.
It's actually about the second assignment. You were talking about starting the second assignment while we work on the first one,
Yeah.
so we deliver them at the same time.
That's right.
Are you still going to do that?
Roughly, yes. Yeah. So one of the things that will take place in the second assignment, that we include storage or databases, and surprise, surprise, it may well be MongoDB, right? So Firebase in this example. But we, of course, if people want to explore other alternative pathways, that's permissible as well. We'll not be hard on this. Yes, so probably about the same time frame, perhaps a few days later, realistically. Please.
So the second assignment is going to be have the same deadline as this one. So basically in
No, you make it a bit later, I think. Another week later. Not too much later, because on the 21st of November is the deadline for your projects, or around 20th of November, because that's the end of teaching. So, or roughly around that time, because we'll do some presentations at the end. So you want to give you enough time frame to actually deal with this. I would say latest at the end of October would be the deadline for the second assignment. So there will be an offset, given that we have slight delay now. So it's a bit of a, to make things easier. We'll probably push out the assignment by next week, the second one, so the variation of it. And I think we have our, as Australian would say, ducks in a row. In the sense that we have the necessary technology to do the second assignment, because the main difference is that you will be dealing with storage. So you have some intermediate storage you need to access. And the final thing, that's something where you can think about, start thinking about already, what you want to do is to have a project in a group setting. So you pick max group size, 3, I guess, or if needed, we can accommodate larger groups. But to solve a specific problem. Of course, the problem needs to scope with respect to the number of group members, right? So it needs to be sufficient work for everyone. And the idea is there to use what you have learned to some extent. REST, for example, you want to use storage. You want to also use something you haven't learned yet, because there should be a research component, because it's kind of divergent. Or what you would still learn. We'll talk about those things in the upcoming sessions. To actually solve a practical problem. Write a cloud service, use cloud services, for example, use financial services, integrate weather services, work on your shared pet project, then pet project. Another example that people did in the past was to create a personal digital assistant. So you kind of use webhooks. Did Mahesh talk about webhooks to you last week sometime? No harm, we'll deal with this. So you can integrate, for example, your services with Slack or Discord or so on, so you can interact with them directly and use this as a basis for interaction. So in any case, I'd encourage you to start reflecting on potential projects you would want to do in a given group settings. Also look for group members, because you guys need to work together to some extent. I know it's annoying, but you need to do that. And you also need to do it in a bachelor, so prepare for that. So try group settings that work, but also try new group settings that you don't know if they work or not. So use it as an opportunity. But it's time for you to think about some projects. I'll set up a page where you can post some project ideas. We'll post some as well. And then you can, we can, closer to the time hone in, you can actually start working on those in your group. But again, it's still a bit out, but it's never too late to actually kind of remind you that this is a part of this course as well. Okay, so I'll fix the assignment for tomorrow. We'll see each other again at 8:30, sorry. And then we go a bit more into perhaps questions that you might have. And then I'm going to talk about some foundations of cloud technology in a wider sense that we haven't touched upon yet.